If you walk through a forest, it can feel like you're looking at hundreds of separate organisms, a tree over there, a tree over here, maybe a few shrubs in between. They all seem independent, but underground, many of them are connected by fungi. Scientists have named this connection the Wood Wide Web. To understand what's happening, we need to start with the fungi. When you see a mushroom sticking out of the ground, you're only seeing the reproductive structure. The main body of the fungus is usually hidden underground. It's made of thread-like filaments called a hyphae. Together, millions of these threads form a network called the mycelium. Think of it as a vast living web through the soil. Many plants form partnerships with these fungi. This relationship is called a mycorrhiza. The plant produces sugars through photosynthesis and shares some of those sugars with the fungus. In return, the fungus helps the plant collect water and nutrients from the soil, especially phosphorus and nitrogen. This is a huge advantage because fungal threads are much thinner than roots. They reach tiny spaces in the soil that roots can't easily access. In some forests, a single tree can be connected to thousands of fungal partners, and a single fungal network can connect multiple plants at once. This is where things get really cool. Researchers have used radioactive carbon and other tracers to show that carbon can move between plants through fungal networks. For example, a large tree growing in full sunlight may produce more sugars than it immediately needs. Meanwhile, a young sapling growing in the shade may struggle to capture enough light, so carbon appears to move through fungal connections from the large tree to the young seedling. Scientists are still debating how common this is and how important it is for survival, but the movement itself has been observed. There's also evidence that plants can influence one another through chemical signals. Imagine that insects begin chewing on one tree's leaves. The damaged tree begins producing compounds that help defend against herbivores. Researchers have found cases where neighboring plants begin changing their own chemistry as well, implying that signals travel through these underground fungal connections. But in a sense, a forest is less like a collection of individual trees and more like a community. Each organism affects others through countless connections that are mostly hidden from view. So the next time that you walk through a forest, remember that what you see above ground is only a small part of the story. Beneath your feet is a vast network of fungal connections linking plants together. The Wood Wide Web reminds us that nature is often far more interconnected than it appears. If you enjoyed this video, consider commenting your favorite biology fact below. Thank you for watching, and like and subscribe for more science content.